Hello again. So I'm graphing square root functions again, but what I'm doing instead of putting a number in front of the square root is I'm putting a number inside the x with a square root. And I could actually also put a number in front of the x in the square root as opposed to accompanying it, but all that really does is just kind of affects the height again. It also actually affects the starting point as well. But what you want to do when you're making a table is this. And now that I have this example up, it's a lot more clear to explain it. When you're starting a table, you want to take the opposite, yeah, that's a good way to think about it. Take the opposite of this number, which would be 1, and divide by the number in front of x. And that's your starting point. So the opposite of -1 divided by the number in front of the x is 1. That's my starting point for my table. The opposite number of +1 is -1, and you divide by the number in front of x, which is -1. There is no number after x here inside the square root, and then it has to be inside the square root, not outside. Is 0, so 0 divided by 1 is 0. That's your starting point. Now when it comes to making a table, all you do is this. Well, 5 values is pretty good. So you want to take the square root of 0, square root of 1, square root of 4, square root of 9, and square root of 16. That's easy for this one. For this one's a little bit difficult. If you want to take the square root of 0, you got to put in a 1, because 1 subtract 1 is 0. If you want to take the square root of 1, it's 2 subtract 1, 5 subtract 1 is 4, 10 subtract 1 is 9, 17 subtract 1 is 16. That's how I'm getting these tables. Same thing for the third one. -1 plus 1 is 0, 0 plus 1 is 1, 3 plus 1 is 4, 8 plus 1 is 9, 15 plus 1 is 16. So that's how I got these specific values. And I took this magnified graph, and I had to write my numbers beforehand, so I'm not going to struggle trying to figure it out later on, what I have to do. And how does this affect it? Well, it's a phase shift. I mean, when you put a number in front, if it's bigger, it goes up faster. If it's smaller, it goes up slower. If it's negative, it goes the other way. It goes down instead of up. When you do these types of problems, they shifted over either to the right or left. And if you were paying attention to either vertex form or absolute value functions, or quadratics, it has the same effect, which is really quite cool. And you actually even see that in pre-calculus too. And I try explaining that to my students in a trig class. And when you do that, when you can explain it to concepts that they already know, into new concepts, they're like, oh, okay, this ain't so bad. But you got to be able to understand those old concepts first. So let's go ahead and get started. So I'm going to graph the first one in green. So when I substitute in 0, I get 0. When I substitute in 1 for the first function or equation, whichever you want to call it, I get 1, 2, 3, 4. When I substitute in 1, 1 minus 1, 0, 2 minus 1, square root of 1 is 1, 5 minus 1 is 4, square root of 4 is 2. You know what, I'm so lazy, I'm just going to look right there. 3, 4. 0, 1, 2, 3, 4. That's basically what you're trying to do. You're trying to get y values that are whole numbers or integers, not fractions, not decimals, because that's just sloppy. So I want to do this first one in green. 0, 0, 1, 1. 9, 3. 16, 4. Oops. Let's put a -1 there, because I know it's going to come in handy. And again, that's what the square root function looks like. It doesn't go up fast, and it doesn't actually top off like that, pardon me. It keeps going up, not very fast, but like I said, it keeps going up. Now I'm going to look at this next one where it's subtracted by 1. What basically happens is this. If you want to figure out where a square root starts in, you take the opposite number and divide by the number in front of x. So 1 divided by 1 is 1. Its starting spot is going to be at, in blue, 1. It's basically the same thing. When I substitute in 2, it's at 1. 5 is 2. Almost identical in terms of graph. Still goes up, but what happens is instead of starting at the origin, it starts at 1, 0. And that's all it is. It's just a phase shift. And this one starts at the opposite of this value divided by the number in front of x, which is -1. Do it in black. basically same type of function, except it just starts at -1, 0, which is really quite cool. Now if you want to do your domain and range for each one, the domains are different, the ranges are exactly the same. Range is the set of y values. I'm going to go ahead and do the range first because it's the easiest one. Include 0 goes to infinity. Include 0 goes to infinity. Include 0 goes to infinity. Domains are different though. This one's going to go from 0 to infinity. Pardon, 0 to infinity. This one's going to go from 1 to infinity, the second graph. And the third graph is going to go from terrible infinity there, -1 to infinity. So that's what happens when you put a number inside the square root of the x. Be careful though, because if this were a 3 and this were a 2 in front of the x, then you would take the opposite of 3 and divide it by 2, and that would be your starting point at -1.5. So you just got to watch out for that. But it's very similar, like I said, to absolute value functions and quadratic functions. Yeah. With that said, I hope that makes sense for you. But for right now, have a great day. We're going to add a number after the square root and see what it happens. And if you've been paying attention to the lessons, you'll already know. But we'll wait till then. Okay, have a great day. Goodbye.